So if you could recall that we have a problem of trying to do the material balance for an evaporator, okay, with a bypass provided, okay, when there is a bypass, okay, and then we know that the component here is M1 with 0.12 kilogram solid and 0.88 kilogram water per kg, okay, and then we have M2 here, we have M4 here, we have M3 which is the water, we have only water, there is no solid leaving evaporator, and then we have M5 here, and the requirement for M5 it should be 0.42 kilogram solid per kilogram and 0.58 kilogram water per kilogram. Okay, so first of all, it's about drawing the process flow chart. We know that this is a splitting point. Okay, so this is a splitting point. So by right, the rule for splitting point, this should also have 0.12 kilogram solid and 0.88 water. So I just label accordingly like this. Similarly, with the flow here, which is this is M2, M4, M5. Okay, let me name this is M6. So this is 0.12 solid as well as 0.88 water, which is this is the rule at splitting points. Whenever we split it, the composition stay the same except that the flow rate. Okay, another information that was given is that whatever left evaporator have only 0.58 solid and 0.88 water. Okay, so how do we perform the material balance for this particular process? And you have to bear in mind that, okay, so this is the mixing point. Okay, this is the splitting point. Right. In order for us to start first, is actually we need to choose the basis of the calculation. Okay, so what is actually entering here, we assume this is as 100 kilogram juice. Okay, and we have also here as evaporator, and then there is water only living here. So this is M1, M2, M3, M4, M5 and M6. Okay, so in order for us to start first with the solving the balance problem for this is actually we need to first of all perform the overall balance. Okay, let me use different color for this. So we need to perform the overall balance first. Okay, so the overall balance here is M1 is equals to M3 plus M5. Okay, so that is one overall balance, which is for overall boundary. We do it for overall boundary because we only want to concentrate on this point, as well as this point. Okay, so we have one equation, it is overall balance, and then we have another equation which is for solid of the orange. Okay, so we have 0.12 multiplied with 100 equals to 0 plus with 0.42 here. Okay, so we have 0.42 solid, 0.58 water. So we have here 0.12 multiplied with 100 equals to 0 plus with 0.42 multiplied with M5. Okay, that is one equation. For another equation, we look at the water, which is 0.88 multiplied with 100 equals to, okay, M3 So we do not know what is M3, but we know that that stream contains entirely water. There is no solid of orange over there. Plus with 0.58 and 5. Okay. So please do not solve yet. Right? Don't jump into solving it yet. But try to investigate first what is the degree of the problem. So right now we have 3 independent equation. Okay. Sorry, we have 2. How many unknowns we have? So this is supposed to be 100. So we have 2 unknowns, okay, which is M3 and M5. And then how many independent equation we have? So we have 1 is here, okay, so this is 1 independent equation. And then we have another one which is either one of this, okay, either solid or water. So we pick one of it. So we have 2 independent equation, alright. And then we have 2 unknowns. So 2 minus 2 unknowns minus 2 independent equation is equals to 0. So this is a solvable problem.